About. Introduction to Power System Operation and Control. Power system is a huge network consisting of generators, transformers, transmission and distribution lines and loads. The generators, driven by turbines, steam or gas or hydro turbines, convert energy from natural sources into electrical energy. This electrical energy is utilized in many ways for the ease and comfort of human beings all over the world. Electrical energy is the cleanest and convenient form of energy for transmission from one place to another. In early days, the power system consisted of isolated generating stations and their individual loads connected through radial lines. But at present the system consists of several generating stations running in parallel and feeding a high voltage network which them supplies a set of load centers. Several such systems belonging to different regions are again interconnected to form what is called a power pool or a multi-area system. Interconnection is done for the sake of economy and reliability of operation. All these developments have increased the complexity of the system from operations point of view. The power industry, therefore, requires specially trained people called system engineers who perform the following functions. 1. Load forecasting. 2. Unit commitment. 3. Load scheduling. Load frequency control. 5. Load flow study. 6. Reactive power compensation. 7. Assessment of the dynamic behavior. 8. Future expansion planning. 1. Load forecasting. Like weather forecasting, load forecasting is the estimation of daily, weekly, and seasonal load demands in advance. The most important characteristics of the power system is that electrical energy cannot be stored. It has to be generated whenever there is a demand for it and has to be dispatched soon after generation. Therefore, load on the system should be estimated in advance to get an idea about how much power has to be generated. 2. Unit commitment. Once load forecasting is done, the next problem is to select the units that will supply the forecasted load of the system over a required period of time. This selection of units out of n number of available units is done with some criteria. The criteria is to select the combination of units that will give a minimum production cost as well as provide a specified margin of the operating reserve, known as the spinning reserve. This procedure is known as unit commitment. 3. Load scheduling or economic dispatch. After the selection of units to be operated is over, the next procedure is to schedule loads to these units economically as far as possible. Load scheduling in the presence of only thermal plants is studied first. Next, the scheduling of load in a system having both thermal and hydro stations will be studied, which is called hydrothermal scheduling. In both the cases, the aim will be to find a loading schedule which will involve minimum fuel cost. 4. Load frequency control, maintaining the nominal frequency of the system, 50 Hz, through suitable controls. It is achieved through balancing generation and load. 5. Making a load flow study from time to time for getting an idea of the voltage profile of the system. 6. Then, voltage control is done usually through reactive power compensation by synchronous condensers, static capacitors, or FACS devices located at suitable points of the system. It need not be done necessarily in generating stations. 7. Assessment of the dynamic behavior of the system during disturbances so that proper preventive action can be taken up. 8. Evaluation of the reliability index of different modes of operation for future expansion. To perform the above functions, offline mode and online mode computers are used by system engineers. An offline mode is one in which the input data are provided by the human operator and then the computer makes the necessary calculations with the help of the program stored in its memory. Functions like load forecasting, load flow analysis, etc. are done in this mode. In online operation, computers receive the input directly from the system. Functions such as load frequency control, economic dispatch, etc. are examples of online functions of computers. System engineers operate the power system through ensuring safety, quality, reliability, and economy. Safety is achieved by protecting the equipment such that, for example, generators do not exceed their nameplate ratings. This aspect is incorporated in the optimization procedure by defining equipment constraints. Quality is about maintaining voltage and frequency close to their normal values. Wide deviations in voltage and frequency from rated values are not allowed. Reliability is like ensuring continuity of electric supply so as to maintain a balance between power generation and load demand. Like in every industry, supply-demand balance is important in power system as well. Economy is the final aspect in the order. Power is produced at minimum cost so that it can attract buyers. In our course, we are going to study about some of the above functions segregated into 6 units as follows. Unit 1 is about load scheduling of thermal plants. In Unit 2, we study hydrothermal scheduling. Unit 3 is unit commitment. Unit 4 is load frequency control 1. And Unit 5 is load frequency control part 2. Finally, Unit 6 is reactive power compensation.